Hey guys, happy Thursday. So of course I'm not there again today. I do apologize. I'm getting pulled out for all these meetings. But what I want to do today is keep going with what we were doing yesterday. So trigonometry, missing sides of a triangle, day 2. So again, finally, we figured out, hey, with using trig, how can we find the missing side of an actual triangle? The past few days we've just been setting up problems, and yesterday we finally got a chance to actually take a look. How do we solve for a missing side, right? Using sine, cosine, and tangent. I want to make sure I practice with that today. I have 4 examples here I want to do with you guys, and then you have your class activity. All right, so let's jump into it. Again, today's objective is finding missing sides. Okay, using sine, cosine, and tangent. And again, don't forget SOHCAHTOA, guys. Please make sure you have this memorized, have it down. I cannot guarantee that I will leave that up on the board for upcoming quizzes. So again, memorize SOHCAHTOA. Okay, so again, sine is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse, and then tangent of theta is opposite over adjacent. Be careful. Try not to accidentally flip those guys around. All right, and again, remember the skill, the basic skill that we need to have here, going back to Algebra 1, is how to solve a one-step, two-step equation. So for example, here, 5 is equal to x divided by 2. So the idea was, hey, how do I get rid of this denominator here of dividing by 2? What's the inverse? You multiply by 2. Whatever you do to one side, you do to the other. And again, the whole reason I did that was so that these 2's will cancel out right here. And I'm left with just x on the right-hand side. And then 2 times 5 is 10. Yesterday we saw that, hey, over here you'll have sine, cosine, or tangent of something, some degree, times the number out in front. And of course, in this case, we got x equals 10. Now, this one was a little bit more kind of complicated just because it's 2 steps rather than 1. Again, still, how do you get rid of dividing by x? Okay, well, we kick it over to the other side by doing the inverse. You multiply by x. Whatever you do to one side, you do to the other. So again, these guys cancel out. Now you're left with 20 times x, which is just 20x, is equal to the 40 that was left over. And then we divide both sides by that 20. And we're left, again, 20s cancel out. You're left with x is equal to 2. So again, that's that basic little foundational Algebra 1 skill that we need to solve um, our trigs here, our trig problems here, where we're trying to find the side, a missing side, excuse me. All right, so what I want you guys to do is, yeah, please copy down this triangle, right? I want to run through this one more time with you guys. I'll do one, I'll let you guys try one on your own, I'll do one, and then I'll let you guys try one on your own. So take a second, copy it down. All right, so it says set up an equation that expresses the measure of AB. So from A to B, I'm looking for this side right here, the distance from A to B. I don't know, so I'm gonna use a variable x just to represent I don't know. Okay, I'm gonna set up that equation, I'm gonna solve it, and round my answer to the nearest tenth. But again, it all starts with where are we standing? Well, look at the degree that they give us. They give us that this degree is 40, so why not use that as our reference angle? That's where we're standing. That's going to be theta. So again, if I go directly across, this makes this the opposite side. Okay, across your 90 degrees, this in this direction will always be across the 90 degrees, will always be the hypotenuse, and that just leaves our last one down here. 13 is our adjacent. All right, and the question I ask myself at this moment is, what do I know and what am I trying to find? So I know that my adjacent is 13, and I know that my hypotenuse is what I'm trying to find. So again, if I took a look at SOHCAHTOA, again, this is why it's important to write it at the top of your paper. You don't have to constantly keep writing it. So if I took a look, hey, what has adjacent and hypotenuse? Well, adjacent and hypotenuse, that's going to be C, which stands for cosine theta is equal to my adjacent over my hypotenuse. Okay, well, let's set up this problem. Let's write that relationship here. So if I say cosine, but again, I don't want to say theta. Where was I actually standing at? What are the degrees there? Cosine of 40 degrees is equal to, and be careful the way that you write it, adjacent comes first up top, so that's going to be 13 over my hypotenuse, which was x here. And again, that's just setting it up right there. We were doing that last week. So the question is now, how do you solve for x? How do we solve for that missing side here? Well, I have to get rid of that x by multiplying by x. Whatever I do to one side, I do to the other. Now again, the reason I did that was so that this x and this x cancel out. I'm going to bring down x times cosine 40 is equal to 13. But again, that cosine 40, you have to treat that as a whole number right there, okay? You cannot separate that. So again, how do I solve for x now? How do I get that x by itself? Well, this is where, what's the opposite of multiplying by cosine 40? Well, we have to divide by cosine 40. Whatever I do to one side, I do to the other, okay? Now again, cosine 40s cancel out right there. I drop down the x is equal to 13 divided by cosine 40. But of course, I want to know what the actual value of that is. So again, if you have Android, the nice thing is you can just plug that into the calculator as you see it. You put 13, you hit the divide key, you put cosine 40, and it should give you the answer. If you're on iPhone or if you have one of my calculators, all right, you're going to have to hit 13 first. I'm going to do that on my calculator right now. 13 divided by, and then when you write it, you're going to hit 40 first. And I'm going to hit the cosine key. And right now I have 0.766 and goes on so on my calculator, but I have to hit equals one more time and it's going to give me 16.97. It says round to the nearest tenth. So this guy, if I take a look at the 7, it'd kick it up to x is equal to 17. So again, that represents x here. The distance from A to B is a distance of 17 units. I don't know if that's feet, centimeters, inches. But again, use a little common sense here. Check your answer. If you go directly across, that was our hypotenuse. Our hypotenuse should be our longest side. 17, well, that's obviously longer than 13. And I'm pretty sure if we found our opposite side, 17 would still be the longest side. Okay, so take a second, guys. Pause the video. Okay, try this problem on your own. When you're ready to check your answer, hit play, and I'll run through it. All right, guys, so I paused the video, and then I did a little bit of work here. So again, where was I standing at? Well, first of all, what am I trying to find? Find the length of PR. So from P all the way out here to R, I labeled that as my X here. All right. Now, again, our job is to where should we stand first, because that's going to determine what's opposite, what's adjacent. So again, they give us 75, so why not stand there? That means that opposite of that is going to be the 37 over here. Okay, across the 90 degrees, that's going to be my hypotenuse, which was X in this case, and then adjacent is the last man standing here, the last guy. Okay, now again, ask ourselves, what do we have? I have that the opposite's 37. What am I trying to find? The hypotenuse, which is in this case X. So what uses opposite and hypotenuse? Well, opposite and hypotenuse, again, that's going to be sine. Sine of theta is equal to opposite over hypotenuse. Okay, well, it actually makes sense. Let's actually plug in the things that I know. Well, I know that my reference angle, sine of, where was I standing at? 75 degrees, is equal to, what's my opposite? That was 37 over my hypotenuse, which is X. And of course, we have to do a little bit of work here before I can plug it into my calculator. All right, so how do I get rid of dividing by X? I multiply by X. Whatever we do to one side, we do to the other. Cancel out my X's. I have X times sine of 75 degrees is equal to 37. Now again, I want to get that X by itself. I had to move it over so that I'm allowed to move over the sine of 75 degrees by dividing. So there we have it. Sine 75s cancel out. You're left with X is equal to 37 divided by sine of 75. And again, this is where you take out your calculator, right? And you plug it in. Now again, please be careful. If you're on Android, lucky you, plug it in as you see it. 37 divided by sine of 75. If you are on my calculator or iPhone, okay, I'm going to hit right now 37. And I'm going to hit divided by the division key. And I have to hit 75. And then I hit sine. And right now my calculator is reading 0.9659, blah, 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 right? I had to hit equals one more time. And I get X is equal to 38.30. Or if I round it to the nearest tenth, that would just be 38.3. So again, what's the distance from P to R? That is a distance of 38.3. Now let me check. That was, again, that's our hypotenuse. That should be the longest. Use a little common sense here. If that's the longest one, well, that one's 37, 38. That's obviously bigger. So, okay, I know I'm on the right track. All right. So let's jump over to this next example. Example 3, it says find the length of side AC. So from A to C, I don't know what that is. Excuse me. I'm gonna label that just X. Okay, that's what I'm trying to find. Now, of course, let's go through and let's label the things that I know. My reference angle here is 24. That's my starting point. That's what they gave me. So I'm gonna go directly across. That is my opposite. Across the 90 degrees is my hypotenuse. And then the last guy here, 8.9, is my adjacent. Okay, let me ask myself that question again, those questions. What do they give me? They give me adjacent. What do I want to figure out? My opposite side, which is X. So let's go I should have copied this before. All right, so what has opposite and adjacent in it? That's going to be tangent. And again, that's opposite over adjacent. So tangent of theta is equal to your opposite side over your adjacent side. So if we actually make sense compared to this problem, I would say tangent, not of theta, right? What was theta? I was standing at 24 degrees, is equal to, what's my opposite side? Well, that was X. That was what I was trying to figure out. Over my adjacent, which is 8.9. So that's the setup you guys should have had. Now again, how do I solve here for X? I need to get rid of that 8.9. Well, what's the inverse of division? Multiply 8.9. Whatever I do to one side, I have to do to the other. So I multiply this side by 8.9. 8.9's on the right, cancel out. Now again, make sure you guys show your work. Try not to skip steps right now. Okay, so I put 8.9 times tangent of 24 degrees is equal to X. Make sure you guys are showing this work until you get the hang of it. And of course, on any test, you'd want to do that. In case anything goes wrong, I can give you guys more partial credit. All right, so now that I have X by itself, I just have to plug this into the calculator again. Android, lucky you guys. Plug it in as you see it, 8.9 times tangent of 24 should give you your answer. Okay, now again, if you are on iPhone or my calculator, I'm gonna hit 24 first. I'm gonna hit the tangent key. Right now my calculator is reading 0.445, blah, blah, blah. And I'm going to multiply, hit multiply times 8.9, and I'm going to hit equals, and I get 3.962, and it goes on. But if I round to the nearest tenth, this 9 would have to get kicked up to 4.0 is equal to X, or just 4. So this side right here measures, this opposite side measures 4. Right, and again, that's not the hypotenuse, so it's okay if it's a little less than my adjacent. These guys should be the smaller ones. The hypotenuse should be the largest one. All right, guys, pause the video here. Try this one on your own. When you're good to go, hit play. All right, guys, so here I showed a little bit of work that I did. So again, they're asking us to find the length of PQ. So from P to Q, I had labeled that as my X. I didn't know what that was going to be. All right, well, that's what I'm trying to figure out, I should say. All right, now where was I standing? Well, they gave me my reference angle 63. So I came across and I said, hey, 6.0 is my opposite. Across my 90 degrees, that's my hypotenuse. And last guy over here is my adjacent. So again, what do they give me? They give me opposite. What am I trying to figure out? My hypotenuse. So what has opposite and hypotenuse? That's going to be sine one more time. Dang, a lot of these are sine. But again, it works the same way, guys. If you had adjacent and hypotenuse, then that'd be cosine. If you had opposite and adjacent, that would be tangent, right? It all pretty much works the same way. You just have to be careful, sine, cosine, or tangent. All right, but let's plug in everything I know. So I know that sine of theta was 63 degrees, is equal to my opposite side, which is 6, or 6.0. I'm going to put 6. And then my hypotenuse is X. All right, let's go ahead and solve this. Okay, multiply by X, multiply by X. I need to pause the video here. I'm running out of time, and then I'll show you guys all the work. All right, guys, sorry, I had to pause the video because it only lets me record for 15 minutes. All right, so again, here's all my work that I did. At the end, I got X is equal to 6.7. And again, it makes sense. It's the longest side hypotenuse. It's larger than 6.0. All right, guys, here is your class activity. Why isn't it going? There is your class activity. You guys have 6 problems. When you are done, go check your answers with my sub. If everything is perfect, please turn it into the inbox. Have a great day, guys. I will see you guys tomorrow.